I guess it's go time.
Well, good morning, everyone. For those of you who may not know me, my name is Pete Tokren. I'm the Atmospheric and Oceanic Sciences Systems Admin. Welcome to the Unidata Python Workshop. We'd like to thank Space Science and Engineering for bringing these guys in. I was told I was off camera last time. I should be on camera because we're recording it. Space Science and Engineering was responsible for bringing these guys in from Boulder, and AOS is providing the room and the equipment and me to help out. We're pleased this morning to welcome Ryan May and Sean Arms, some Unidata Python program experts, software engineers, that will be teaching us about accessing weather data with Python, and hopefully a lot of underlying Python as a part of that. So I'll turn it over to you.
All right. Good morning, guys. Just a little about me. I spent about 15 years in Norman at the University of Oklahoma as a meteorology student, going through undergrad, grad, taking a little while to do a PhD, and then decided, actually before finishing, decided I liked software a whole lot more than worrying about research and grants. So here I am at Unidata, and I get to teach and write grants and maybe not research, but still pretty much same kind of thing, but I get to work a lot on software. And so I get the opportunity to come and teach you guys. We run a workshop every fall. And so I do a lot of Python stuff. I also work a little bit on the Threads data server, if you know that. Sean, you want to give them your life story?
Life story. So I'm a Cancer. I like girly drinks and long walks on the sand, sandy beaches. Yeah, so I was on the long road to the PhD land as well. Which, by the way, how many of you are students? How many are working on your PhDs? Do not leave before you finish. Bad idea, bad time, bad things will happen. Don't do that. Even if you're almost done, you'll end up rewriting the stupid thing. So stick it out and then finish and then go off. Anyways, yeah, my background is in meteorology as well, boundary layer meteorology specifically, and it just so happens that I was at OU at the same time as this guy, and we spent almost every morning in his office drinking burnt coffee talking about computer stuff, whether it was Git or just taking care of your code in general and what are best practices and whatnot. And so we ended up at Unidata, which was perfect for us, and we're here to help you guys out, and that's what we do. So for those of you that don't know, Unidata is funded by the National Science Foundation. We're a pretty small organization, about 23 people total. That's admin staff as well as programmers, or script monkeys in my case. And we exist to help make your lives easier. And so there's been a call for more tools being available in atmospheric sciences using Python. And Ryan has stepped up to the plate to really try to push forward on the gaps that currently exist. So there are a lot of Python tools out there for atmospheric science, but there are also still a lot of gaps that are remaining. So.
All right, quick question. How many of you guys have heard of Unidata before today? Okay, so I don't need to go through that. Good. And how many people in here have never written a line of Python code before? Okay. So our general workshop, we don't go through the basics of Python, but I don't want to leave you guys behind. So we'll cover the bits and pieces we know as we go through. And if you see something up there that you don't understand, please don't hesitate to stop me. And that goes for general. We want this to be interactive. We want you guys to get out of this, something useful, to get a lot out of this, so that, you can take this back and put it to use. We're going to pack a lot of material into the next 2 days. So a lot of it, it'll be taking away resources that you can come back to and run through again. And then after doing it a couple times, hopefully it'll sink in so that you can make good use of it. So by all means, stop me if I'm going too fast. If you don't understand something, you have a curiosity, especially in the case if you don't understand, odds are 2 or 3 more people in the room don't get it either. So good so far. All right, so first thing up this morning is Git. How many of you guys have used Git? That's what the survey results said, so good, you weren't lying. How many of you have used version control other than Git? Okay, about half. All right, so for those of you who have not used version control before, version control is a software tool that allows you to checkpoint your work, checkpoint your code. So I have my set of code I'm using to generate figures for my dissertation or figures for a paper. Maybe some Python code, maybe some MATLAB code. And maybe a common way that you're going to do this would be, okay, I edit it. I have my working copy now. This one works, generates things how I like. I'm going to copy it over to this backup copy. And now I'm going to edit the live copy. And I get halfway through that, and then I leave. And I come back a week later, and I have this half-working thing that I'm not sure what state it's in. We're going to start again. We're going to make that copy and start editing that again. And you keep making these copies. That's a form of version control that's not very rigorous, not very easy to come back and really make sense of it. So what version control software allows you to do is take snapshots of that and say, okay, I made this change to my code. Here's the reason why. And then I made this change, and here's the reason why. And you have this log of all the changes you've made, and you can easily roll back to a version you know is working, to a version before you made a change. And so it frees you to work with your code and not be afraid of breaking things and not be afraid of, oh, can I get that back to the state when I know this paper was working? Because the worst part with code is you have it working, you edit it, it works for this case. But 6 months later, you do something, and all of a sudden it doesn't work anymore, and you wonder why. So version control helps to solve that problem. So we'll run through some basics of Git, and we'll be using bits of Git to get our workshop materials and things like that. So that's kind of how we're laying the foundations here before we get to the real cool stuff. So starting off with Git, I hope we're all at least able to use the command line. If not, that'll make it a little bit harder, but we'll go slow. So don't let me get ahead of you guys. So at the command line, everyone see that at the back? Good. All right. So I want to make a repository for some code that I'm going to write. So the first thing I'm going to do is make a directory. Make dir my Python code. You can call it whatever you want, as long as you can follow along. The name of the directory is not super important here.
If anybody gets stuck along the way and things aren't working either, let us know, because Sean or I can wander around and help get things working.
Okay, so I make that directory, and I change directory into it. Change into my Python code. So to set up Git, you say git init. So you get a message out that says initialized empty Git repository. My shell is set up with a few more bells and whistles, so I have this thing over here. You guys, odds are, do not have that. Don't worry about it. So that initialized a repository for Git, and now I'm ready to rock and roll with Git, to start tracking code and things like that. One other thing to go ahead and set up here for when we want to take these snapshots, especially if you're collaborating with others, but it's good for purposes if you want to work with this site called GitHub to put your code online. Good to go ahead for your commits and set up your name and email so that those are in the log messages of who made the changes. So we can do that with git config -- set user.name. I'll put my name here. You can put yours. Oop. Okay, it wasn't set. What was it? Add. All right, my bad. So get that off there. Git config -- add user.name. There we go. And git config -- add user.email. And I'll put my email address here. And that only sets it on the repo we're working on, the repository. So I'll use the word repo, short for repository, your collection of code and all its history.
Can you show the lines before this?
Let's see. Oh yeah, there we go. Good idea. So I think the ones we want.
Okay.
There we go. So it's really, other than the one that I did wrong, it's make a directory, change into the directory, get in it. These three.
Okay. So
And then the two configuration lines. We all good so far? Anyone not good, I guess is the question.
Yeah.
All right. So the first thing I'm going to do here is I need some code to actually manage here. So I'm going to use VI to open a file. You can use whatever text editor you want to edit a file within my Python code. What's the best one for the people on the Linux machines? They said they had
gedit or Emacs is on there.
gedit, Emacs, VI, and edit. So I'm going to go in the Vim and I'm going to say, I'm going to call it calc.py. And for starters here, I'm just going to make it real simple. The basic Python program that for programmers we call the Hello World program. Make a program that only prints the line Hello World. So in Python, that looks like this. So print parentheses Hello World. And it doesn't actually have to be perfectly here. I can just go back in there if you need it. For the version control stuff we're doing right now, getting this exact is not super important since we're not actually ever going to execute this code. So really, we're going through the motions of putting stuff in a file, tracking the changes to the file. The contents of the file are, well, the contents are not the focus here. So as long as you have something to put in the file that you can track, that's what matters. All right, so I'm going to quit out of that. And now to say, okay, if I do git status, so that's a command you're going to be running a lot. That it's had the way to ask Git, what's the status of the repository? Let me see here. Okay, we're on the initial commit, so we're just starting here. And it says, oh, we have these untracked files. So it's files that Git knows nothing about. So if I want to tell Git to track that file, actually, if I want to tell Git, so Git works, if you're familiar with, for those of you familiar with CVS or SVN, you kind of just commit all the files changed at once, generally speaking. With Git, you have this two-step process of, I need to tell Git all the changes that it should put together in one commit, and then I commit. So here I want to say git add calc.py.
Hey, Ryan?
Yeah.
If you all are following along in a PDF somewhere in the background, this is going to be a lot different. There are people following along, I think, in Julian's Git.
Oh,
yeah.
My. The PDF is a good reference to have for the history of Git, or if not history, but for the use of Git. But we're trying something different here to be a bit more hands-on rather than going through the slides. So if you're following all those will be a good resource to refer back to, but I won't be talking to those particular slides at all this morning.
Is that the link from the?
It is the link. I tried to have a link for something there, but should have been more specific on, that's more of a reference material than it is the materials for this part of the course. Thanks. All right, so we're going to do git add calc.py. And that's telling Git, I want to add this calc.py file to the list of things that it should be added when I make a commit, when I want to checkpoint and say, okay, this is where I've committed things. This is a state of code I want to snapshot. So if we do git status again, we still see we're on the initial commit, but now we see, okay, changes to be committed. We have a new file, calc.py. So I've told Git that's the file I want to be committed. And if I had other files I've edited, I could add those as well here to put together a list, but I don't have to include every file I've modified. It's kind of one of the nice parts about Git is it's very easy to achieve the granularity you want in what you snapshot. You don't have to include all the files you've modified if you have some junk test code sitting around that you don't want committed. So now I've got the file added. I can say git commit. And then I need to give it a message to save. Those of you on at least OS X and Linux, it would put you in Vim to do your commit message. So instead, we can just give it the message on the command line with the -m. So I say, I'm going to say first commit of calc.py. Again, the exact message isn't important. Just we give it a message so that we know when we come back later, what was I doing here? Why did I make this change? Why is it useful? All right, when we do that, it gives us a message. Okay, one file change, one line inserted. We actually created this file. So first commit in Git. If we want to actually see the history and see what, see this commit's been included, we can say git log. If we look at the log, we should see every commit we've made here. And so we see got this funky looking number here. We see the author. So there's that user information we put in, the user.name, user.email. We've got the date of when we made the commit, and then the message we gave it. Everyone good up to this point? Or am I going too fast for anyone? Cool. All right. So I've got that file. It doesn't really do much, so I need to go add something to it. So go back in there and edit the file. So go back and edit calc.py. And I'm going to add a function in Python to do some kind of silly calculation here. So for those of you new to Python, to declare a function, just say def and say the function name. So I'll call it Fahrenheit. And now I give it the argument to the function. We'll say Celsius. And we're going to return Celsius temperature of 1.8 plus 32. Again, for purposes of Git, we're not really concerned with the exact syntax here. All right, so we've got to do the file again. Now, if we do git status, and now we see we're not getting that initial commit message anymore, but we see changes not staged for commit. So before it was saying we have this untracked file, this file I know nothing about. Now Git says, here's a file that you've edited. You've made changes to this file. So I want to commit those changes because I want to make sure I have a history of adding that function. Once again, it's git add calc.py. And then we'll go ahead and commit with git commit-m and a message. Yeah.
Okay. So what's the purpose of this two-step process versus like a CDS where you commit direct?
So with the two-step process, you have the ability to only add certain files to the commit. So you can work across 6 different files. And then when you want to make commits, you can break it up how you want. So you can only, say, okay, these 2 files are kind of one logical change I've made. I've edited 6 files to add, the display of temperature to my program. And this first commit adds a temperature calculation function. This next step added some kind of widget to the user interface. And this third step added some tests, maybe. So you can do it, you can break it up, not even at the file level. If you really want to get in, you can commit only parts of changes to files. And so it's just basically giving you the granularity to assemble your changes as you want in your history.
So if I've done my add and I make more changes, can I diff those before I commit?
Yes. So, okay, if you've done your add, the add only adds, actually, let's go ahead and let me demo that thing. So that wasn't on the books, but I'll show you what that kind of looks like. So if we add another line here, if I go back in and edit calc.py and say, we're just got another print statement here. Print done. If I get out of that, I just added a print message, just some line of code. And I can, well, first off, if we look at the log right now, we see the 2 commits we've made. We have the first commit down here, and then we have the second commit I made, added the function Fahrenheit. So just those 2. And we also see right now, currently, we have calc.py modified. If I add calc.py and look at status, it says it's modified. So then I can go back in. Okay, I started to do it. If I can look at git, I can look at the changes here by doing diff. In this case, because I've already said added it and it says it's a change to be committed, I need to add this staged part for the diff. So I can see, if I just do diff, here, start with diff. If I do git diff, there are no changes. So diff ordinarily shows you the changes you've made. But since I've already added them to be committed, I need to tell diff to look at the staged changes, things that would be committed. If I've done that and I say, oh, I don't like what I've done here, I'm not actually ready to commit this, I can go back in, edit the file, and say, okay, I want a better, I left off a quote here. And maybe I want a better message. Just change the line somehow. Go get status now. Now we see calc actually has 2 different statuses here. We have some changes to be committed in calc.py. And then we have some more changes that are not staged for commit. And if I look back at git diff, we can see this difference. And it has the part where I had the original change I made to the file here. And now it has also the modification I just made to that line. And so now I can just add it again. do a git status. Now we see it's just, okay, changes to be committed, all the changes to calc.py. And there are no unstaged changes. Commit that. You originally had another question in the back.
No, I saw her hand raised.
Oh, okay. Thank you. All right. Who have I lost? Wow, giving me far too much credit. All right. So we go with the basic operation of edit, add, commit, edit, add, commit. So the next thing that Git does that is a pretty frequent part of the workflow is branches. So if you're familiar with CVS and Subversion, branches are a very heavyweight, pretty annoying thing to use that you only use when you really need separate lines of code development. In Git, branches are cheap, easy, and used frequently. And so what a branch is, in general in version control systems, is just a way to, you kind of want to take your code, go work over here, test some things out, and be able to make commits without changing, your main history. So you kind of like a tree, you're forking off, and you've got maybe this line of your main development, and I'm going to come over here and do some things and test some things out where I can still checkpoint my work and see how things are working and have a history of the changes I've made. But I can throw that away without ever, needing it merged into the main, back together. Or when I think it's ready, people can be using my main line of stuff. And then when I think this feature is ready, I can merge the branch back in. And if you think about Git being used to, say, manage the development of the Linux kernel, so the core of the Linux operating system, you can see how having a branch over here to go work on USB drivers and a branch to go work on your hard drive controller and all these different branches, and you need to manage hundreds of developers working across the world, you can see how branches can become a super important feature. But even for just using it by myself, when I want to go test out one feature, I'll go make a branch for that. Because frequently I don't get something done. I need to go back to the main one and quickly fix a bug, or, I just decide I need to go work on this feature right now. And so you can have these multiple parallel sets of history. So to make a branch, we could say git checkout -b. So the -b is what tells it to create a new branch. And we'll say, we'll call the branch devel. I am really uncreative when it comes to naming things, so I apologize for the boredom that the names are going to create here. So now the same thing, we've changed onto a new branch. I have the little marker over here, but if you want to know what branch you're on, we can say git branch. So we get a list of the branches. We have master. That's the default first branch that Git creates for you when you do a git init. That's kind of the convention that master is the main branch, but that could be named Fluffy Bunny if you wanted it to be. And then we just created this devel branch. And so here it is. And then it has a star next to it saying, that's the branch you're currently on.
Does it matter whether you use single or double quotes?
With which one? Because I didn't use any quotes when I created the branch.
Oh, okay.
It just printed it out in the quotes.
Never mind.
And it shouldn't matter which one you use if you did quote it. All right, so now I'm on a development branch, just a separate branch. I'm going to test out adding a new function to my file. Edit calc.py again. Come down here and add a new function. I just realized I didn't explain for those new to Python. One of the things, the biggest shock is that Python doesn't use curly braces for blocks and has no end function, end do kind of thing. So you define the blocks of code using indentation. So to define what code is within this function body, it's just whatever lines are indented. So until it reaches another unindented line, the code in there is considered within the function. You can use tab or spaces. The only rule is don't mix them. So be careful with your editor settings so you can see whether you've got tabs or spaces. But otherwise, that's a holy war item in terms of who prefers what. It's a good question. So we've added a function. Quit out of this. Who knows what's coming next? Throw it out there. We're going to add the file to be committed, so it's git add. Git commit. Is that too far to the bottom for you guys in the back? Okay. All right, so one more commit. And so if I look at my log, see, we actually got so much it's causing it to scroll on the terminal here. So if we want to go away, if we want maybe a shorter looking log or just a quick look, we can do git log -- one line. So that just shortens it. Doesn't give me this full big number, just gives me a little bit, and as well as just the message here. But that saves us from scrolling on the terminal if you just want a quick look. The important part to take away is, okay, we've got these 4 commits in our history here. And the last one here is the add Celsius function.
What's the difference between git add and then git committing instead of just doing git -a?
So git A is just gonna, it's the, for lack of a better term, it's the sledgehammer approach. You're just doing it all. So there's nothing wrong with that. It's whatever change history makes you happy. If you're just fine with everything I've put in this, everything I've changed in the directory can just go in there, then that's fine. And that is a shortcut way. So he was saying git commit, we do git commit. I don't have any changes, so nothing's going to happen right now. But you can give it a -a, and that will automatically add every file you've modified. And yeah, I'll add every file you've modified. Not the untracked ones, but everything it knows about. You can git commit -a and then give it a message here, whatever. And so that can save you the process of adding. But if you want the finer grain control, I've got some files that have junk in it that I really don't want committed. That's when you use it. All right, so now let's go back to our master branch. So git, the switch branches, it's checkout. Hit checkout master. We see the message, okay, we switched to branch master. Now if we do that log, See, all right, we only have 3 commits now back on the master branch. So devel has that commit, master does not. If we're happy, you know, we're like, okay, devel, that's good. That calculation function needs to go in my main branch of development. We want to merge it in, merge those changes together. Let's git merge. I want to merge in devel. So what I'm saying here is merge into my current branch what's on the development branch. Get this message about it updating. Okay, change calc at 1 file change 3 insertions. And if we go and look at the log again, okay. So git log -1 line again. See, okay, now master had gained that commit we made on devel. And since we're done with our development branch, we can say git branch -d devel and get rid of it. And git does try and save you from yourself. So it checked when I went to delete that branch, were the contents of that branch or the commits on there, were they all reachable from master or the current branch I'm on or other branches it's attached to. So if we hadn't merged yet, it wouldn't let me delete that branch without forcing it to delete it. But at least by default, it does try and protect you from losing stuff.
Question.
Yeah.
So like the CVS or SVN, you have absolute path physical copies of branches that are the same. Does it kind of just do it all in a hidden file and then it replaces the actual, so you run an absolute path with one file. Does it just kind of do it basically a Linux copy in the background and actually replace the file? It's kind of, you know, compared to CVS or SVN, it's a little bit like magic.
Yeah, so it's, without getting too far into the weeds, Git's tracking actually the content of the files. And so it has a full set of the history of the contents of things within its repository structure on disk. So when you're making branches, you're not actually doing any kind of copies. You're just kind of, it's a...
It's kind of saying any lines that this was added, this was taken out.
Kind of, it stores some diff information like that. A branch is really, so you see these numbers over here? Those are technically hashes. Just if you don't know what a hash is, it's kind of a computer way of throwing a bunch of things into a bucket and getting a number out of it. And so these hashes kind of form a chain of this happened and this, before it was this, and before it was this. And so branches are just a cheap pointer to one of these hashes. And so creating a branch is really cheap. It's just however many more commits you make on top of that. And even then, it's, you know, storing diffs against previous content and doing things like that. Everyone who's not with me at the moment, or is everyone good with this so far? Because we've gone through this pretty quick, and I don't want to lose anyone. But we're also going a lot more smoothly than the last time I did this, so I have more I can teach on this. I just want to make sure I don't lose anyone behind. All right. So for the sake of argument, let's go into calc again. Actually, before I do that, take a new branch, git checkout -b. Add, I'll call it add func, trigger function. back into our calc.py again. I'm going to add here, in between these two, I'm going to say define define meters to kilometers. Take up argument meters, and we'll return 1,000 times meters. Or, excuse me, bad Ryan. Meters divided by 1,000. All right, so I'm going to add them. Just going to go ahead and commit this. And we'll go ahead and just for fun show the -a. So we won't bother adding this time. We'll just put the add here with the -a flag. Made that. Now we're going to go back over to master. Here we're going to edit calc.py. We see we don't have a function in here. And on master, I'm going to add, let's see. Define gram to kilogram. So on each branch here, we've added a function right at that spot, doing two different things with different code. So if I save that, hit it again. Okay, so calc has now been edited on and committed on both branches. So if I try to merge in my add func branch, okay, it's detected that that we have edited on both. So it's trying to merge the changes I made in calc.py on one side, on one branch, and trying to do it on the other, and it can't. It says, okay, there's a conflict here. I can't do anything about it. You need to do it. So it says fix conflicts and then commit the result. So if I go and look at that file, okay, what's going on here? What we get here, we have this big block of equals here. And above it, we have this bunch of less than signs and head. What that means is on the master branch, the branch we're on right, we started on, we have content in this spot that looks like this. On the branch I tried to merge here, which it says add func, I have the one content that looks like that. And so it doesn't know what it should do. Is, you know, this one down here an updated copy of that one up here? Should they both exist? You know, or should neither exist? You have the ability to do whatever you need to here to try and rectify how those two things should be merged together. So in this case, what we can do is just delete that line, delete that line. I want both functions to exist in the final merge. We just make sure that the contents of the file, I mean, what we're doing here is basically saying this is what the file needs to look like now. Now I can save that.
So I'm not sure why, but mine just auto-merged with the recursive strategy.
Did you add the function in the same spot in the file? Does the content of the file look good? That's the, all right, then you got lucky. Every now and then the merge algorithms in there are pretty good. So it can often, I mean, I specifically hit that spot so that I was trying to make them conflict, but it's, if you've just edited different parts of the file, it's usually pretty good about merging those together and there's no problem. So you got lucky in this case. You defeated by example. Well, for those of you who didn't have it work so easily, you know, we've edited the calc and it's in a good state. If we do git status, you know, it says we're on branch master. You have unmerged paths, fix conflicts, and run git commit. And then here are the files that are that we've not marked as having merged. So we've gone in and we've edited it now. Now we need to tell git, okay, we handled merging that file. So that's, again, it says here, git add file. So git add calc.py. Then the last step here is git commit, and I'm going to run it without the -m for one particular reason here. If I run it like that, anytime you run it like that, it'll bring you up into an editor where you can type up your commit message, and you want to write a nice long descriptive message because you spent 3 hours figuring out a bug and you want to save yourself figuring it out again. Here, because we were doing a merge, it gave me, it's giving me a message saying, okay, we're doing this merge. And it also listed here what files were in conflict when we did the merge. And so we can actually leave this in the commit message so that we know what we had to fix here. And we could say, okay, we're merging and I had to fix calc.py. So I will get out of Vim here, save the message I've edited. And now if I look at my log, I'll do the big one so we can see it all. We see we have this merge here. And we see it has the message, and we left in the line saying, okay, here's what conflicted when we did the merge. Now, if we notice, we look at the history, we have both the commit that said add the gram conversion and the commit that said add the meter conversion. So we still have both commits from both branches.
You merge select files between branches, you have to do it as a whole branch.
Have to do it as a whole branch. Because these commits aren't, I mean, they can tell you what files were changed, but fundamentally these commits are tracking entire sets of content of the repository. Tracking changes to the contents of the repository. So it makes things like a rename of a file, really it's just attaching a different name to this block of content, as opposed to saying, okay, this file existed in this directory and this file existed in this directory. Instead, renames are just, oh, we just point a different name to this blob of code or binary or whatever.
So if you have in your branch something that you've done that you really love and everything else is just stupid, you delete them, stash them, what do you do? So
on a branch, so you've committed, on a separate branch, you have committed a bunch of changes and you really only want one of those changes. Okay. So you guys are not really throwing hard ones at me here. We have time for this. So, how do I want to do this? Okay. So if I go over, first I'm gonna delete that branch we made. Git checkout dash B.
The branch you deleted after you did the merge, the branch still kind of without, was it the master?
Correct. The one I deleted, and actually we can still look at it. We can git log. We give it, and so we can't give it the add func, but if I give it that number, it's actually a hash, and that represents the branch, and it's still floating around there. If I do that, we see that only had the add meter conversion. So it was not updated. Just the master one was updated.
So you should often delete branches and start new branches.
Yes, yeah. No need to leave them hanging around. Use them as you need them, and then get rid of them when you're done. Yeah.
I have a side question. Do you prefer to create like these little tiny, well-named branches and then delete them, or keep like a one developer branch that's always running and updating with the master?
Boy, that's a workflow question more so than a Git question. But my usual workflow is just a logical branch. We can argue about the well-named part of these on my branches, but certainly I'm going to go work on something to read NextRed NIDS products. That'd be a branch. I have another one sitting around for fixing bug number 365. And so I don't generally keep a one developer branch around. I think a lot of it depends on how your workflow works in terms of how you cut releases, how you release your software, and what branches you're releasing off of. So if you only want certain, there's one workflow that's just like I described. We have one little feature branch, we put it back in, and then we release off master whenever we do a release. Another workflow is, I think that it actually has a name of Git flow out there, where I have my main branch I'm releasing off of. I have a separate development workflow that merges in these small branches. And then only when I'm happy with the state of the development branch do I merge in the development branch into master to make sure all these, my 15 different developers haven't done things that don't work together. That's so stylistic. We could, go into that one forever. But I can tell you, Git supports whatever workflow you want in that regard. So as far as deploying in the commits here, you git checkout dash B. Oh, I'm just going back to devel here. Then out of my development branch, and I made, just playing with a bunch of different things. So go ahead and add a new file for a change. Calc's had enough work done on it. So we'll add I am just blanking on what to call this thing.
Oh, yeah.
Speed.py, sure. Fine. Velocity. Takes arguments distance and time. Return distance by time. Okay. Git add speed.py. Git commit -m. And velocity function. And we could say add mlog.py. I'm going to play with adding some logging functions. Find function log me message. And all it's going to do is print the message.
You're going too fast for me. Can you go
Okay.
back to what you were doing?
Absolutely. So we'll quit out of that.
Okay, so you made a function Speed.py.
Yeah, but I just put something in speed.py. For the purposes of this, whatever is fine in speed.py. I'm just trying to get away from adding text files that have like a word in them, because that's the usual way we do these demos. Create a new file, speed.py, put something in it, add it, commit it. Now I've gone ahead and made another new file, log.py. And I put another function in there. Anybody else still need a little more time here?
Can you show log.py?
Sure. I'll go ahead and add log.py, since we shouldn't be scrolling up the screen here. Oop. Learn to type. And commit it. So now we have two more functions on devel. So does anyone not have log committed? All right. So now I'm going to go back to the master branch. So git checkout master. I've come back a week later. Okay, I want some things off devel. Let's see what's on devel. So
Viewing the current branches that have been created.
git branch. So I'll show you all your branches. Let me see. I'm on master. I have a devel branch. And actually, if I want to see now, I've forgotten what did I do on devel. So from the master branch, I'm on master, but I can, when I do the log, I can say, give me the log instead of devel. And I'm going to give it the one line just so I don't go off into scrolling land here. Okay, so we see here's what's on the development branch. We have this add logging function and add velocity function. Well, in hindsight, the logging thing wasn't a really good idea that worked out for me here. But I want the velocity function. So the way to just grab one of those commits is a command called cherry pick. So I do git cherry pick, and I just give it that hash, that 7 digits is what it has there. So in reality, it has like 1640 or something. We only need enough so it can uniquely identify it. And so we give it that. And there we go. We see this. It looks like it grabbed the right thing. I want to double check. We do an ls. There's my speed.py function. We don't have log.py, but we do have speed. Contents of speed.py look good. Now if I do a log on the master branch, here was our merge commit we did a while ago, and we see the velocity function commit, but we don't see the log one.
Okay, so the reason I would want to do small commits is so I can cherry pick. If I'm doing one file at a time, I'm able to cherry pick much easier than if I
Absolutely. Yes. No way. And yeah, I've often gotten in situations where, wow, I really wish I had committed it smaller. And I don't want to go into it here because that's deep Git stuff, but your commit history can be malleable if you want it. You can go back and there's a function called rebase that allows you to kind of edit your history. And you can go in there and squish together commits, edit commits, change commit messages. That's really good for you working by yourself on your own little development branch. You want to avoid doing anything like that on branches you share with other people. Because what rebase will do when you squish together things, it changes these hashes. And so then people who have old versions of your code, it just doesn't mesh up together well at all. But for things you're doing locally that you haven't pushed out to the world, that's a really nice tool to be able to clean up a bunch of work in progress commits you've made too. Here's the final one where I don't need the history of, coming back and working on this 4 different days. I just want, here's the first time I did this function, and then we'll have history on top of that later as I fix bugs over time. So the last thing we're going to do, we're done with this repository now, unless anyone has any other questions about Git. We've kind of reached the end and beyond of what I was planning on teaching on Git. So good on you guys. The last thing we're going to do with Git here is we're going to go grab the workshop materials. So I'm going to get out of this directory. I'm going to change directory up a level. I'm in my home directory. You can be wherever. I just advise you not to be within that Git repository we were just playing with, but be somewhere else. And so we've been working with Git locally on this machine. Now I want to go get a Git repository that exists outside on another machine. In this case, I'm going to get a repository from GitHub. And so the command for Git to do that is clone. Man, emails go nuts. Git clone. And that would be https://github.com/Unidata Python Workshop. So if I run that, get this thing, it's cloning into Unidata Python Workshop. So that's a directory locally it's cloning into. The remote server does some things, and now we're receiving data from GitHub, and we're probably destroying the Wi-Fi network at the moment. Well, maybe not the Linux machines, but anyone who's working on a laptop.
Wasn't too bad on Monday.
SSL?
Are you doing it on your
We'll
own
go
machine?
double check. So you shouldn't need to authenticate the clone because this is a public repository. We're just downloading stuff. We're not actually modifying anything on the remote end. There we go. Now it's picking up. All right. So, is it still working for everyone, or is anyone else having problems with this? Because if this doesn't work, we're kind of stuck. So we need to make sure we get everyone with this. Since this is we actually have now downloaded the workshop materials. So we actually keep our workshop materials up online on a GitHub repository, and we track changes using Git. So.
User error.
That's right. Problem exists between people and share.
Pepcac.
The URL wrong.
Well, asking people to type a URL based on what's at the screen of the front is kind of sadistic, but I don't know an easier way to do that. The fact that there was actually only one person out there who mistyped it is amazing.
Yeah.
And I only typed that from memory because I've done it a bazillion times. All right. So is anyone still downloading? Okay. Well, while we're downloading.
That's what I was going to do. So how many of you write papers using LaTeX?
You wish you knew?
Anyone? A few people?
Sean, you can use LaTeX here too. The break.
I was going to say, if you use some sort of markup language like LaTeX or Markdown, Oxygen, any number of things, that's really kind of text file based. You can actually use Git to track changes as you're going along and writing your paper. Or as you update figures. Now the thing with figures and imagery in general is that Git's not super smart about binary logs of stuff. It loves text-based stuff. But so when you do a Git diff between two images, you'll actually have two of those images stored in a repository. Not just the original original image and then the bytes that are different. So your Git repositories can get big if you're not careful.
Is there any way you can ignore it, right? So is there any way to have some sort of like version system on the side of the imagery that's not different to that? And then have something
It wouldn't necessarily be integrated together.
It is on the thing from here though, just because.
I mean, I did my dissertation
You can save the directories that you're
revision of everything
copy
you
of what
did.
you had.
And it wasn't terrible.
You know.
There are some projects, I can't remember off the top of my head the names. There's at least one Git extension or thing on top of Git that tries to do that kind of, here's an external image that exists over here. It's not in the repository itself, but still gets tracked in some way.
But of course, if you had your code living alongside your document, then your code, if you thought ahead of time to do it like this, your code should be able to reproduce the images that are current for the publication. So if you had those living side by side in the same Git repository, you can tell Git, ignore any PDFs, ignore any JPEG or UPS files. You don't want to store anything like that, just the text. Then at any point, you should be able to, what I did for my dissertation is I had one big function that was regenerate images. And so if I updated like a bug fix and some of my processing code, I would just run that script and get all new imagery. And then my LaTeX was set to reference those images. So I could just re-render it, and then there's my updated stuff all at once.
I know people who've used make files with LaTeX and scripts like that to just make my thesis. That's beyond, I know I didn't even go that far, but I know people who have, so. All right.
Well, some journals do have LaTeX templates now.
Sure.
Like ACT.
Mhm.
So if there was a way to do that, that's actually really useful.
It's a good way. It's absolutely feasible to, you just set up make and reference the right files. It's, standard make file challenges now, but makes a tool that's very well suited to say, okay, this file is updated, so I need to rebuild my LaTeX. Oh, all these figure files have been updated. I need to rebuild my document. Oh, this script changed, so I need to regenerate the images. Can track all those kinds of things.
Once you put the upfront time into getting that set up, then you can copy and paste all that stuff for a new one. So, reference this LaTeX style sheet from this journal this time.
All right.
It makes it a little simpler.
So, we all done downloading now? Good. All right. We're moving on from Git now. So, any last parting quick questions, or we can discuss more in the break? Cool. All right. So, we now know how to do software change tracking, and we've downloaded the workshop materials using Git. So, next up, we need to start setting up a Python environment. And so we use a tool called Conda. It's put out by Continuum Analytics. They're a company that does software in Python for the sciences, do consulting work and training, and they've put out a great tool here that helps manage environments for Python. And they do a Python distribution you may have heard called Anaconda. And so Conda is the tool that powers that in terms of managing the environments, managing downloading packages, and dependency tracking for the packages and things like that. So who doesn't have mini Conda installed on their computer in front of them? If you're working in the lab computers, you have mini Conda, or Anaconda works.
Do we need mini Conda specifically, or just plain Conda?
Plain, you mean install from Anaconda?
Yeah.
Okay, yeah, Anaconda is fine. Either of the two. I usually start with mini Conda only because it's not a 2 to 4 gig download. And I don't need a lot of the machine learning and image processing stuff they put in there. So I just start with mini Conda. But as long as you can do this at the command line, Conda -- version, and it doesn't give you an error, we are set to rock and roll. Is everyone good with that one? Cool.
Oh, which Python version are you?
We're going to base on 3. Everything should work on 2, but Python 2, the core development team has put out the date of 2020 that they're going to stop doing bug fixes on Python 2. So I'm advising everyone, any new code you write, if it can be done in 3, do it in 3. And save yourself the hassle of when the date gets here, the Python 2 goes away, or at least is not maintained by the core development team. Red Hat and company will probably still do 2, but the era of free software developing 2 is coming to an end. I mean, that's still 4 years away, but there's at least a date now. All right, so we've got Conda installed. And so the first thing we're going to do, we have this, Conda has this notion of environments. An environment is, at its core, just a list of packages that are installed, but it allows you to have different Python environments alongside each other. So going back to, say, the research model here, I can have one environment set up that is locked in. I never change once I get one working for my dissertation. And I actually got into that situation finishing mine of, oh, my normal environments that I've been developing in are broken. Things don't work. I've got library problems, but my dissertation environment is set in stone and it works, and I'm not touching it again until that thing is deposited. So environments allow you can, without risk, go test out some packages and not worry about it breaking code you depend upon, because you can just throw away that environment and have a separate, stable environment where you're not installing random packages. And of course, again, it does things smart. It's using every environment doesn't necessarily have its own copy of packages. If there are common files between environments, those are shared. Using things like hard links and stuff. So it doesn't necessarily bloat your computer to have 6 different environments. So to create an environment, You say Conda create -n for name, and we'll call this, I don't know, what do I call this? New Python, sure. And I can say Python equals 3 to tell it, okay, we're creating an environment. I want to have Python installed in it, and we're going to say I want Python 3. So technically speaking, Conda can work for, it's not just Python specific, but will work for things like R. And for Python, it'll install generic C libraries and things like that. So Conda's mission in life is to be a cross-platform package manager, coming at it from a perspective of things needed to do data science. So if I run that, it's going to go out to anaconda.org, look around and say, okay, great. Oh, crap. Hold on. My settings are different from yours. Pay no attention to the man behind the curtain. There we go. Okay. So now everyone should look like this. Everything's saying defaults. So we say, yes, that sounds good. You'll have a little bit different because you'll need to go out and download everything.
So ours doesn't say defaults or our settings and stuff.
You want to take a look? It might not be critical. Sean can take a look and see. What does it say?
It just doesn't have defaults.
Oh, okay.
No, they're called better.
Okay. I know why. If it doesn't say defaults, don't worry about it. As long as it doesn't say things other than defaults.
Does it say error or file name?
Error, or just if we had things, these are basically Conda's a notion of channels, so different people's sets of packages out there. And I think it's a setting I've turned on that says always display the channel names that you're downloading from. And we'll cover actually adding some channels in a second. But to start off, I wanted everything from defaults. So if it doesn't say defaults, don't worry about it. Did anyone get an error running this?
Yes, util. So I loaded it.
That happened yesterday too.
Okay, I
So
want
it did Conda install and it loaded it. Okay.
Complained that you didn't have it, so you couldn't run it. So you had to install that first.
Mhm.
that's
PS util with a hash mark, and then it downloaded what I needed.
all right. I'm gonna come back to that maybe later just to take a look because I'm curious about that. But as long as you're good to go,
I think I am. How do you tell whether you're ready to go?
Did you manage to do the Conda create?
Yeah.
Okay. Then we'll assume until we're proven otherwise that things are good. Okay, so that creates an environment. And we see now we're given this line to activate this environment. We do source activate new Python. And all that's doing is it's modifying your environment variables to point to the location of the Python that goes with this environment. So it's not changing anything on disk or anything like this. It's just changing your settings within your shell here. So you see it's pointing to, it's replacing this directory that's in my path now with this one to point to the Python, the new Python's binary directory.
That does only work in Bash. Does not
Yes.
work in TC shell.
Do not, if you're running on Linux, TC shell, or I guess on OS X, regardless, TC shell will not work with this. And I don't think there's, at that point, you just run Bash and
Start
then,
Bash shell and
yeah.
there.
there's really no other good workaround here. You can run your environments if you just put this directly in your path, but as far as the source activate, that's not going to work. On Windows, there's no source in front of it. So it's just activate. Do we have any Windows users in the house? Oh, wow. Okay, that should keep
That's
things.
good.
From a perspective of encountering weird things I'm not used to, that's great because I never work on Linux or work on Windows. I test things on Windows, but I have other people's computers to do that for me. Okay, so no problems running source activate. We're all good. We've got, we can say Python -- version. This is what it says. It might be easier if I don't highlight it. All right. So we have an environment. We can run Python, but now we need some libraries. Oh.
Python 3 backward compatible, so if you go to something like Python 2 or like Python.
No, and that's why there's been a transition for like Python 3 was specifically the backwards incompatible release. They wanted to clean up some of the language stuff. The good news is, since you're just starting out, I assume, you could just start with Python 3 and pretend Python 2 doesn't exist.
And if you have stuff in Python 2, for the most part, unless you're calling into C code or something like that, there's a script called 2 to 3 that will go in and update your print statements and fix imports if needed.
The biggest change from 2 to 3 that is probably 80% of people's code migration is print went from a keyword in the language to a function. So it used to be print as a keyword space string. Now it's print function call with parentheses string. There are a few other little things, but the code is 90% the same.
Default libraries and course and stuff are pretty much the same.
There are a few they renamed to be consistent naming. So basically the 2 to 3 change was a lot of consistency and just trying to remove warts that had accumulated over 15 years of things that hadn't been well thought out. Since then, I'm sure there are a few things that haven't been well thought out that they've accumulated since, but this is a one-time thing they've pretty much said. It's already been painful enough. Doing this backwards incompatible again would be unthinkable. And I still haven't even gotten out of this one yet. So now we have a Python environment. We need to install some packages. So Python has a lot of useful packages that you can import. Essentially, it's like including in C, but including and linking in C, I guess. And so, you can make your life a lot easier by finding other people's code to go reuse rather than starting from scratch. And so with Conda, we can do that really easy. And so, for instance, here we'll do Conda install NumPy. And so NumPy is an array library. We'll see later. I didn't have to download anything because I already had it, but you guys will need to sit and download. This MKL one will take a while. But NumPy is an array library. If you've used MATLAB, what it gives you is a nice array object that you can do math with, and it to speed up your code by handling looping over all your values in C rather than doing looping at the Python level. And so it's probably the most foundational package of doing science in Python. Everyone's still downloading, I'm assuming? Yeah. MKL is big. That's the Intel's math kernel library. So NumPy will actually link to that for a few of the linear algebra functions it provides.
So I moved my directory after the fact. How do I verify my environment? Like, if I moved the directory because I didn't like where I had it, I moved it, does it keep the environment?
You may need to reactivate the environment so that your path is set properly, but that should, I can't emphasize the word should enough, that should be fine other than just your path needing to be updated.
Okay.
If not, you just need to create a new environment and go with it. But because every now and then it does tweak some of the shell shebang lines at the top of scripts and things.
Question.
Yes.
So once I have, say, new Python set up, when I go to work in a different environment, is that there, I don't have to download everything again, or do I have to redo everything every time?
No, the downloads, so it caches the downloads for you, and it'll reuse those as appropriate. Now, if you come back days later and do a new install, new versions might be available, and so it'll end up downloading new versions. But otherwise, you can create new environments with the same sets of packages without worrying about downloads. And certainly MKL should stick around. We shouldn't have to worry about that again after this. So I have no idea. How are we doing on downloads? Done, still going?
Still going.
Okay.
Like 60%.
Well, now that everyone else is off the network, it should be going faster. All right. So we installed NumPy, and just for sake of argument, we'll do a couple other things here. We'll install another package called Plotlib, maybe. And that's a plotting library that gives you MATLAB-like plots. And we'll definitely be discussing Matplotlib and NumPy a bunch more this afternoon. And for purposes here, if I want to install a specific version, I could say matplotlib equals 1.4. So I don't want the latest release. I have, for matplotlib, this might not be necessary, but sometimes you want a specific version of the package. And so that's how you can specify that there, is giving it a restriction. Why is it downgrading NumPy? That should be all right. So you can see here, actually, it tracks dependencies as needed, and the matplotlib 1.4 packages only work with NumPy 1.10.4, and so it'll downgrade that for you to keep your environment consistent and not broken. I'm assuming people still need to download a bunch more things now that I had you install more stuff. Okay.
Are you on? Yes. I'm surprised I heard that wasn't public. There is a rename environment option, right?
Yes. Conda, if you type Conda ENV, I think you should get the man page for it.
What's the command to find out the version of the package you have?
So, you want to see what's in your environment. You do Conda list.
Oh, that tells you the version.
That tells you the version of everything that's in there. So we see we have matplotlib 1.4.3, NumPy 1.10.4.
Is that's only going to be in your environment, though, right?
Correct.
Okay.
You can have different versions in different environments.
Yes, that's one of the big things about the environments is you can install different versions to different environments. It's really good for testing things. Trying to see if Conda list has a way to. Yeah, so you can do Conda list and give it a -n name to tell what environment to look at.
Oh, you're in CSH.
So just type bash. Yeah. And so now you should, let's see.
Why is that? Okay. So who's still downloading things at the moment?
It should have done it. So, yeah, so that should be in your path. And it's possible that
Yeah.
later you're going to run into some
No, shoot,
issues
that's
with
it.
like the next
If you're going to grab code from some places online, you have to, you want to create an assistant username and email address
Go ahead.
from machines that you work on. Source that every benefit.
Yeah, I didn't cover that. So the username and email is really only important for commits. So if you're pushing code back out to, especially GitHub, and we'll talk about GitHub more tomorrow, but that's an online code hosting and code collaboration site. And the email is important there to be able to tie your commits to your user on there. So in that regard, it's important. So when we did the git config earlier, we reset it on the repo. If you do -global, really this one's the important one. So the --global up there at the front, that tells it to set it globally in your home directory settings. And that'll apply across all your projects by default. You can then override that on a per repository basis if you need to.
So you don't even have to issue that command in a repository.
You don't have to. Now I've got some where I have my default set to either my personal email address or my UCAR one here, and then certain repositories for personal work I keep set to my personal email address. That answer it, or?
Yeah.
Okay. Did it finish downloading?
Yeah.
Cool. All right. So now, luckily, it does cache those downloads because having just installed it, I'm going to say, hey, we installed stuff. How do you remove packages from an environment? So I didn't waste everyone's time. It just
Found it.
go. Thank you. Click the brain over. Conda remove. And let's just remove matplotlib. Well, yes, I'm going to remove just matplotlib. So it didn't. It's not going to remove all the dependencies it downloaded, but it'll remove what you asked it to. Now, if you remove a dependency for things, it will say, okay, I need to remove all these packages so that we don't break them when we remove this thing. So it'll go the other way. So that's adding and removing packages. If you want to try and search for a package, Conda search. I want to search for every package that has array in its name. And we get this bit array thing, and we get X array. Or if I know something exists, I know it's SciPy. Oop, Conda search SciPy. A whole lot more. You can, I knew the package existed, but now I can see the different versions that are all available on there. And they have a long archive of packages that are available for SciPy. So that covers installing and searching for packages. Any questions about that so far? All right. So I'm going to change directories into that Unidata Python Workshop directory we cloned from GitHub. I do an ls in here. I see there's this file environment.yml. We call it a YAML file. And that's good enough. What that file is it's a configuration for the environment. And so it has a name and lists channels. As we kind of touched on, channels are alternative sources for packages. And then it also lists a whole bunch of dependencies in here. And so this is the specification for the environment we're going to use for the workshop. And so instead of doing everything by hand, we can just say conda env create. And it'll look for that YAML, that environment.yaml file in the current directory. And it'll create and set up the environment for us in one fell swoop. I already have it set up, so mine's not going to do anything. Those of you on the...
Mine's already set up too.
Okay. For those of you on your own systems, that should be working. If you get an error on yours, that would be weird.
Yeah, I think I ran that right in previous game.
That's all right. Kill that Wi-Fi.
So here you're setting up environment variables? Is that what it's
This
doing?
is more setting up the Python environment for the workshop. So it's taking care of doing the environment create, or the conda create-n, and it's handling installing the packages that we've listed. So I've got a list here in that environment.yml file that lists all of the packages we need for the workshop. And so it's handling installing all of those. Another note for you.
All right.
That needs to go. Or at least the version specification. So it doesn't need to go, but it's not needed anymore. All right. People still downloading, or are we going? Okay. Uh-oh, an error. 500 type error, or?
No, like. By all means.
Hi there.
So these packages like metpy and siphon, those are on the Conda website, or is that part of the basic list? So if we want to do Conda install package name,
So
or is that especially for this workshop?
those packages are hosted. Can't scroll that right now. There's a channel listed in that configuration called Conda Forge. And so Conda Forge is a community maintained set of packages beyond Conda Anaconda's or Continuum's default set of packages. And so there's a whole community archive of packages there. And I don't know if it's going to make a difference. I'm just hoping. So Conda Forge is a community packaging.
Conda Forge?
Yeah, Conda Forge.
So if we wanted to take a look at the listing of packages on Conda Forge.
So if you Google for Conda Forge. Okay.
So if we have a account on GitHub, will that work on this one? Or do we have to set
You
it?
actually don't even have to have an account GitHub to look at it, but if you go packages, it'll link at the upper right. It should take you to a list of the packages. And it's probably 400 some different packages. And so we have our packages from NetPine and Siphon up there. That's kind of where we do things. We don't, Continuum's not packaging NetPine for us.
So then the question is, if there's a package here, what's the best way to bring it up and load it onto your system? If we wanted to add it to our mini project.
So I will do that step in a minute.
Okay.
And there's that. I was going to move that.
That's it. So I just did it the other day.
I think something just went horribly wrong. Just
So the fact that it's on 2.7 is okay.
Mini Conda 2 should allow you to install Python 3 on that. That should, but I'm not encountering what you did there. I can tell you I install use Mini Conda 3 to install Python 2 all the time.
So now that I've done this, yes, but
Change into the workshop directory and then to the workshop and Conda. It's gonna download a whole bunch of stuff now because he's moving that, but that might be good. All right,
thanks.
no problem. Anybody else still downloading at the moment? Okay. So, for those of you on the lab machines, what we do probably need to do is I'm going to source activate Unidata Workshop. All of you need to do that one because that's going to be the environment we're going to need for what we're doing today. Then, for those of you in university systems, need to do a Conda update -- all. I get some entries here. I'll go ahead and say yes. Sure. That right there. So that's how you tell it to update the packages. You can give it individual packages you want to update, or the -- all tells it to do everything. Sometimes that can produce, weird things it's updating, but I just wanted to make sure we get the environments on the machines in the lab as if we just installed them. that should have been quick. So is everyone not waiting on things? Okay. So the question about trying to install things from Conda Forge. So one thing we can do here, boy, my terminal's not very wide. Well, it's gonna have to wrap. Conda install, just like before. And if you want to tell it where to install things from, you can say -C for channel and just give it the channel name, Conda-Forge. You can use other channels, but at this point, Conda.
Be a website, the Conda Forge?
It can be a website, but if you just give it the name Conda Forge, it'll go to anaconda.org and look for it. And so that's probably the simplest way. Before I've used the big URLs, but this is nice and harder to mistype. So let's see. And then I'm not sure I could pick a package here. What don't I have installed? I can just try Xarray. But I'm pretty sure that's already installed. Nope. It gives me a bunch of things. I'm actually going to say no because I don't want to mess with the environment. But that's how you install it from a separate, just one package. I want to go look at a channel. And, if you have particular packages that you need to install from somebody else's channel that's not Conda Forge, you could put that there.
Like GitHub, if there was a package there, like SharpPy
No, that one. So GitHub itself generally isn't used for hosting the packages up there. They're all for Conda, the packages generally end up on anaconda.org somewhere. You just need to tell it which channel on there to use. I've not seen any other alternative hosting for the packages other than anaconda.org.
What was the full command line for Conda?
Sure.
Oh, Xarray.
I gave it Xarray as a package example. Xarray, replace Xarray with whatever package you want to install.
If you add the Conda Forge channel to Conda, when you try and install just a standard package like NumPy, will default by grab it out of this channel or the Conda main channel?
That's a really good question. So if we want to add, so that's one way, just per package basis, you can tell it to install from a particular channel. Instead, you can add a channel to the list of defaults. And so be very careful to not misspell this, or we'll have to go edit the config file to fix it because it can get angry. So Conda config -- add channels. That misspelling's there on the problem. It's here. Make sure you do CONDA-FORGE. What did I do wrong? Oh, I misspelled channels. There we go. As long as I don't misspell Conda Forge, because then it'll try and look for, however you misspell Conda Forge, it'll look for that as a channel, and it'll error out saying, I don't know what that channel is. Could not parse the. So I got an error message. I'm curious if anyone else sees one. Hopefully you guys all work. Good. For me, I think I need to actually go edit the config file. So this is the easiest way to do it. If for some reason you get an error like this, the config for Conda is in your home directory in .conda.rc. So I can edit that file. You don't need to do this, but if you were to get into a situation like this in your home directory, .conda.rc, there's this. I'm not sure why it says it's malformed, but
I keep getting an error that says like my bin Conda directory does not exist.
We're getting that too.
bin Conda directory doesn't.
Yeah, so it's like where everything is bin/Conda does not exist. So I can't really read it.
That's no good.
I don't think it does exist.
All right, so that added the Conda Forge channel to your set of default channels. And I think, so Conda, if I get Conda config -- get channels, we see the, okay. If we're, the original question here was about the order of the packages. And so the order that they're listed here, I think, is the order of priority it's going to use in searching. I think. But if you add it as a default channel, then anytime you do an install, you don't have to specify it, but it might be pulling the Conda Forge channel, the Conda Forge packages first. And actually, Continuum is participating in Conda Forge as well. So beyond just being a community packaging area, it's probably almost a staging ground for things that are going to end up in defaults. Or at least it's starting to move that way.
So, and that since Conda Forge is on top there, does that mean that we would search that first?
I believe so. I need to.
For me, when I did that, it switched. Default is on top of Conda Forge, so it's the bottom.
So looking at this, so I think it'd probably, one of these orders is the true one. So actually, let's just do. Let's see. I'm just going to try it out and see what it lists, what it decides to do. Okay. Well, that's when it's installed. Scikit-learn, machine learning. So I'm installing from Conda Forge right now. There's a lot more logic behind it in terms of build numbers and versions that go behind what it resolves as far as what channel. So really the build numbers are probably what's really going to control things. Build version. All right. Anybody else having problems at the moment so we can get going? Okay, you are.
Your hammer wasn't strong enough.
Really?
Blow away the whole directory and start over.
Is this the same exact error?
Same error.
Reinstall. Any kind of frequency effect. The whole error message here just doesn't make some sense. But it's a file. Go ahead and start down. You just Google committee conduct. Oh no, both of them installed?
So what was the original thing that was that you install? Or what you have to change?
Right.
That sounds familiar.
So you're using Anaconda, you could run a channel.
Right. But I could
Should I blow away the
Might as well.
You work it all.
It's not scaring me to death about this. It's only one computer that's having. There's hope for it.
So let's do this. What is that one working on there?
Okay. How are we working with you? Okay, so I got two down now.
So Pete, now I can go into the config file.
I think so. The kind of CF. Is that true?
What are we looking for?
I missed all those commands out there. So
No worries.
Now you should be able to create if you do a simple, yeah, that's the command.
Just really for the rest of you guys are just yeah.
Can you remove the matplotlib? And then we grab the environment from the
Yeah.
data workshop. That should reinstall the thing, right?
Yes. Well, actually, with the using the config file, we actually created an entirely new environment
Right.
from the set of packages in there, and it'll reuse whatever you've downloaded that applies to the new environment that's being created.
So what happens to the old environment? Is that okay?
That should still be there. And actually, so if you want to see what environments you still have, you can do conda env list. I have a lot of environments. You should not at this point. So here's the new Python environment that we made for testing. And then here's the Unidata Workshop environment. And we see the star that one's active.
So in new Python, the MATLAB library should not exist.
Correct. And so we can do conda list -n new Python. It has a bunch of things, but no matplotlib.
Can you do the history again?
Sure. And Pete, I don't know if you set it out to everyone, but we have cheat sheets for.
I have not sent that
Okay.
out yet. Yeah,
So you guys will get cheat sheets for Git and Conda.
If I remember, I'll send out one for you.
So if you don't get one, bug Pete because he has them.
If you don't get one.
I'll like blow away my Python so I can read. Good.
So actually, yeah. So the last command I want to show you is to remove an environment. So last one here. So conda env remove, and we give it -n for name, and new -python, and that will remove an environment. Doesn't clear out the downloads. It just unlinks all the packages and gets rid of the directory.
What was the flag there? Sorry.
Conda remove -n, n for name. Say yes, and we're good.
Error trying to remove that.
Is it the currently active one?
No.
No. Well, that's fun. All right. Well, that's the last thing I have. If you have any quick questions, I'll go back to you in a second. If there are any quick questions about Conda before we go, we're going into break. So. Well, for one, it allowed us to have one file that said, this is all you need to install. And so we were able, in our workshop materials, here's the environment file that will reproduce an environment of working packages to get you going on Python. So from a pure practicality standpoint of the workshop, that's our big thing. For a day-to-day use of Python, as you hopefully go off and use Python a lot and play with different packages out there, the environments allow you to play with things in a separate sandbox without worrying about things that you absolutely cannot afford to have broken. And so it kind of frees you to play around more without worrying about, oh, now I've installed something that brought in this new version of NumPy that breaks everything. You can be sure, if you were doing things, my production environment stays safe, but my development environment, I can put things in, nuke from orbit, recreate very reliably. And Conda in general solves a lot of problems where in general in Python, pure Python packages are easy to manage and install. But in the sciences, we use a lot that wrap Fortran code or C code or C++ code for speed and just reusing legacy libraries. Those can become a royal pain to get installed, especially for people who don't have compilers, or on Windows you have different compilers. And so Conda kind of solves that problem by providing these precompiled packages that are already built and they're easy to install. So those are the big selling points there.
So I can list and switch between these environments?
Yes. Yes.
So if you're working on a paper and you want to make sure that you can always run your Python scripts and not worry about an update breaking something, you can make a my paper environment or whatever, boundary layer, VML 2016 environment. And you can always switch over to that before doing your coding related to that piece of work. And if you really want to update something, you can make a test paper environment, update it, run the stuff, see if anything breaks. And if not, then you could go and update your environment. But it's a really good eject button. Things do completely wrong. You know, you've always got an environment you can go to.
Let's see.
That works. So make sure you-
So we're coming into break. So let's take a break until 11:15.